So in this graph, we have a function f of x. I can see that it's a parabola, so it's a quadratic function. I can see that it's upward facing. Here at the bottom, we see that its vertex is at -1, -16. We can also see it has roots at -5 and at +3. So if this is the function f, I want to think about what f prime would look like, or some things that we know about f prime. So whenever we're considering f prime, the derivative, we want to keep in mind that this is representing the slope of f of x. So I'm going to take a look at f of x. I see that if I start from, let's say, like an x value of -6, and I head toward my vertex, I see that we are decreasing over this section of the graph. And that's actually true if I started at an x value all the way to -infinity. It is decreasing all the way until we hit that vertex. So this section of the graph is decreasing, which means a negative slope. Okay, so I know that f prime is negative over that section of the graph, because f prime is representing the slope of f. So I could say here that f prime is less than 0, meaning f prime is a negative number from -infinity to -1 until I reach that vertex. Okay, once I move to the right of the vertex, or as I continue past the vertex, now, since the vertex is a turning point, now we've turned around and we are increasing. So f is increasing on this section of the graph, which means that f prime is positive, is greater than 0, because we have a positive slope over this section of the graph. So I know that f prime is greater than 0 from -1 to infinity. Now, I've seen different mathematicians and calculus teachers, some use parentheses here to not include -1. A lot will use brackets that do include -1. I'm going to accept either. The AP on the multiple choice seems to always do closed brackets, so including the -1. But here we're going to just use parentheses to make sure we understand this idea. So everything after -1 going all the way up to infinity, we have a positive slope on our graph, which means that the derivative is going to be positive. And again, everything to the left of our vertex, so all x values from -infinity up until -1, since the graph of f has a negative slope, that means f prime is going to be negative. So let's think about what that means for the graph. So I know that when I'm doing power rule, if I have, so here, we don't know exactly what f of x is. We could write it out because we have the roots. The most important thing is we know that f of x is going to be something involving x squared, something using x squared because it's quadratic, which means f prime is going to have to be linear, something involving x, because when I take the derivative, when I apply power rule, my exponent is going from 2 to 1. So I'm going to have a linear graph that represents f prime. It's going to start out negative and then end positive, which means -1 is where that change happens. So at -1, f prime is equal to 0. Now, we know that also because if we think about tangent lines, here at the vertex, there's going to be a horizontal tangent, and a horizontal tangent has a slope of 1. So this tells me that f prime is equal to 0 at x equals -1. Okay, so for all x values before that, f prime is negative, so negative y values, and after this point, f prime is positive, so positive y values. So this is a very loose graph, but that is generally what f prime is going to look like. Let's see how close we were. So if I switch over, this is my graph on Desmos. And if I open this up, in Desmos, you can type in a function as f of x equals and write the equation. And then you can type f prime of x and it will create that graph for you. So if I turn this on, we can see our line. So just like we discussed before, where we see a vertex on the parabola, we see a root or a y value of 0 for our line, because f prime is representing the slope of f. So where f has a horizontal tangent, f prime will be equal to 0.